OSPF neighbors are sensitive about parameters, and they check those out before they become neighbors. In this lab, you'll start with a lab with 6 working routers that are all neighbors, and you'll break 4 of them so that only 2 routers are neighbors at the end. I'll demo how it works during this video, but you should try it for yourself. Let's jump in. So there's no blog page for this, it's just this video. Let me tell you what the rules are. Download the packet tracer file linked in the description of this video. You'll open it and then see this topology that you see an image of below. So familiarize yourself with the lab, log into the routers, check the neighbor relationships. All should be neighbors with the other 5 to start, all right? Then we're gonna break R2, R3, R4, and R5 in sequence and check R1's neighbor relationships at each step to see, all right, the relationship with R2 failed at the first step, and then with R3, and then with R4, and then with R5. At the end, only R1 and R6 should be OSPF neighbors with each other. So that's the general flow. Now let's review the failure reasons from the explainer video. This is a slide from that, but I've colored it because the ones that are in light blue, which are 1, 2, 5, and 7, are the ones we're going to test, and here's why. 3 and 4, you cannot test in Packet Tracer because they don't. Packet Tracer does not support the commands that you would need to use in order to test it at the current version. When I recorded this video, the current version of Packet Tracer, which was 8.2.2 at that time. Then I'm skipping number 6 because you can configure that failure, but Packet Tracer doesn't fail in the same way as Real Gear does. In fact, it does not appear to fail at all. All right, so we're going to avoid that one. So basically, I've set you up to avoid the ones that are problematic in Packet Tracer. The last 2, I avoid them because with IP ACLs, I haven't gotten to that yet in sequence in the books or in these videos, so that would be a bit unfair. And OSPF authentication is not even covered in CCNA, so I'm avoiding that one. So when the dust settles, here are the 4 from that original explainer video's numbered list of failure reasons that we'll try out here in this ad hoc video. In fact, check the timestamp. This is where you want to come back to in this video if you want to remind yourself of the core of the steps. We're going to go to R2 and shut down the interface, R3 and change the IP address, R4 and change the hello timer, and R5, we're going to replace the network command with a new one. All right. Those are your marching orders. You should do lab now. So I'll give you the proverbial moment to hit pause and go do it. And then I'm going to launch into the demo. So for scenario 1, I've already opened up the packet tracer file that you could have downloaded from the description. And I'm going to focus on router R1 and R2. The routers have been up long enough to where they should have become neighbors with the other 5 routers at this point. So all the neighbors should be up and working. We see some log messages to that effect here. The router IDs are pretty obvious numbers, 1111, 2222, and so on. So show IP OSPF neighbor shows 5 neighbors here on router R1. Let's do the same thing over here on router R2. And let me open that up a little bit so you can see it better. All right, so we've got 5 routers known to R2 as OSPF neighbors as well. Looks like router R6 is the DR and router R4, ironically, is the BDR in this case, but that's not really important to the discussion. What is the first scenario says, let's shut down R2's interface on this common subnet. That interface is gig 000. So let's just go ahead and do that. So config T, int gig 000, shut down, and we'll see some log messages appear pretty quickly here. We see all the neighbors going down because OSPF immediately knows that it can't keep those neighbors up. Show IP OSPF neighbor lists nothing. But over on router R1, notice all the neighbors still appear. But watch the dead time for neighbor R2 keeps going downward because R1 is timing out its neighbor relationship with R2, counting down from the default of 40 for the dead timer. Here we go, 3 seconds, 2 seconds, 1 second, boom, log messages saying router R2 is down. Now R1 has failed its neighbor relationship with R2, and R2 no longer shows up in the list of neighbors. Again, if the interface on R2 can't send any packets, then we can't maintain or create new OSPF neighbor relationships with R2. We should see something similar happen with this scenario too. So on router R1, just to confirm, show IP OSPF neighbor confirms we're neighbors with routers 3, 4, 5, and 6. Router R2 still down from the previous scenario. And router R3 is where we're going to break something this time, but just to show it, show IP OSPF neighbor, its neighbors with R1, and then R4, 5, and 6. Its neighbor relationship with R2 failed because of the previous scenario. So what we're going to do on R3 is change its IP address on that common subnet so it's not in the same subnet anymore. So just to confirm the addresses, let me do this command and scroll it up a bit. On gig 000, the IP address is 172.16.10.3/24. So it's in subnet 10, if you will. And we're going to change the IP address per the instructions to be in subnet 12 instead, put it in a different subnet, and its neighbor relationship with the other 4 routers will fail. So let's do that right now. Interface gig 000, whoops. And then IP address. So I believe that's the correct, incorrect address, if you will, that I was supposed to configure here. There you go. We get log messages right away. So it looks like the neighbor is down. Look at the list of neighbors. So R3 immediately brought down its neighbors. Here on router R1, its neighbor relationship, look at the dead timer for R3. It's now 20 seconds. It's counting down from 40. It's not getting any hellos from router R3, or it's getting them and ignoring them because they don't match. Getting and ignoring, getting and ignoring. And now we're counting down close to 0 on our relationship with R3. 1, 0 log messages. So now R1 no longer has an OSPF neighbor relationship with R3. Here for scenario 3, R2 and R3 are down now, right? So router R1 should have just 3 neighbors left, R4, R5, and R6, as you see there. And we're going to focus on R4, which also has 3 neighbor relationships off its gig 000 interface, namely R5, R6, and R1, as we just mentioned. Now, in this case, our goal is to break things. So once the routers boot up again, they wouldn't become neighbors, but the thing we're breaking in this case is to change the hello interval on R4's gig 000 interface. So if we do a show IP OSPF int gig 000 and look for that setting, let's see. We see the dead interval is 40 and the hello interval is 10. And the lab says, let's change it to 15. If it's any other number than what matches on the other routers, then if they're trying to come up, they won't become neighbors. And if they're existing as neighbors, then the neighbor relationships will fail. We'll see the failure case here. So and we set the hello interval to 15. There you go. But notice we didn't get any of those log messages about the neighbors failing. So the neighbor relationships appear to be up, but notice the dead timers. So we're waiting for the dead timers to fail, and we've changed some timers. So in this case, the failure takes a little bit of time. So I'll just stay here on router R4 while those dead timers fall down towards 0. And then we'll see all 3 of R4's neighbor relationships fail due to that mismatched hello timer. And here we go. 3, 2, 1. There they go. So no more neighbors here on R4. And if we go back just to say check at router R1 again, we see only R5 and R6 remaining over at R1. So we've gotten through 3 of the 4 failures that we're trying to use to demonstrate issues in this lab. This last one's a little trickier config-wise, so we'll get to that in a moment. But over on router R1, just to confirm, we've got only two neighbors left, R5 and R6. In our last scenario, we'll break R5. All right, so going over to R5, what was the lab asking you to do? Well, it said basically reconfigure and put the interfaces in the wrong area. All right, so to do that, you're going to have to remove a network command and add a new one. So let's just do a quick show run and look at the config for a moment. Down at the bottom, this network command we're going to get rid of and replace it with one just like it, except, let's see, we said put it in area 5. Right? That's what the instruction said, so we'll do that. And a few things to check. Show IP OSPF int brief. We see we're in area 0 right now on both our interfaces, and that'll change to 5. And then R5 still has neighbor relationships with R1 and R6 at this point, and those will fail as soon as we remove the configuration. Let's do that. Let's see, let me remind myself that was OSPF process 1 here. So, get into OSPF 1 config mode and do no network. So that'll remove the config. We'll lose our neighbors. If we check the other routers, the neighbor would be down. Now we're going to add the network command back, but now with area number 5 at the end of the command, which will basically enable OSPF on both interfaces. We even get an error message, hey, area mismatch area ID, and we'll see these repeatedly. All right, so that's a clue that we've got a problem going on. But if we retrieve our show IP OSPF interface brief, we get a confirmation that we placed those interfaces in area 5. If you're willing to look quick, you can see those. If we go back over to router R1, we see that R5 is no longer listed as a neighbor, but we get this nice obvious log message telling us that there's a problem over there on R5, which is always a nice help. Thanks for hanging till the very end, folks. Hope you enjoyed doing the lab. Mastering all these different OSPF neighbor failure reasons is pretty important for CCNA, so make sure you soak in, you remember them, and you're confident about how those work. Of course, if you're new to the channel, please subscribe and click the bell to get notified. As always, comments and likes are very much appreciated. Thanks for hanging out. Talk to you soon.